So slicing of the NumPy arrays. So what do we mean by slicing of the array? Let's say we have this array A here, which looks like 1, 2, 3, 4, 5, 6, 7, 8. These are the elements of this array A. Let's say the indices of this array A are, this is 0, 1, 2, 3, 4, 5, 6, and 7. These are the indices and these are the elements of the array. Now taking a portion or extracting a portion of this array is called as slicing. For example, I want to get elements from this location to this location, right? I want to get these 4 elements, or I want to get these 3 elements, right? Or I want to get these last 2 elements. That is called as slicing, right? Extracting the part of the array is called as slicing. Now, while taking the slice of the array, we need to mention the starting point, name of the array, the starting point, from where you want to start taking the slice starting point. Then colon, you have to mention the ending point. That means till what location you want to take the slice. This ending point is exclusive of exclusive. This ending point is exclusive. What do you mean by exclusive? We'll see. This ending point is not included while taking the slice. Okay, we'll see that ending point. And the last is the step size. Step size means, let's say you want to get only this element, then after that you want to exclude one element and go to next, that is this one, then exclude one and go to next, then exclude one and then go to next, right? This is step size of 2, right? You are taking a step size of 2, 1 and 2, right? Again from 1 and 2, 1 and 2. That is step size. So while taking the slice of an array, you should mention the starting point, ending point, and the step size. For example, if I want to get, let's say I want to get this portion of this array. I want to get this portion of this array. So array A, what is the starting point? You are starting at 0. What is the ending point? You want to take till 4. That means till location 3. So the ending point must be 4. Must be 4. Why? Because it is exclusive. This will not be included. This will not be included. This location element will not be included. That's why this is exclusive. That means if you want to take a slice till 3 location, then you have to write the ending point as 4. And what is the step size? You want to include all of this. That means all consecutive elements, 1, 2, 3, right? Like this. So the step size is 1. So this is what you will have to write in order to get this slice, right? Now, if I want to get the elements on even locations like 0, 2, 4, 6, right? So A of start at 0, right? Go till the last location. What is the last location here? Last location is 7, but you will write here 8, right? 8, which is not there in this array. 8. Or when you are going to, if you don't know the end location, when you are going to the last location, you need not mention this. If you are starting at 0, going till end, right? And you need not mention the location here, right? Then take a step size of 2, right? What we said, start at 0. When you are going till end, you need not mention a location here. If you are going till end, you need not mention a location here. Same is the case for start. If you are starting at 0, you need not mention a location here. That means this is equivalent to A colon colon. That means you are not mentioning starting point. By default, the start is 0. You are not mentioning ending point. By default, the end is last location. And taking a step size of 2. This is this is equivalent. These two are equivalent, right? So that's why this will give us the slice. This will give us the elements like 1, 3, 5, 7, right? Because next if we take the step size of 2 from here, we will go out of the array, right? So let's see this example. Let's execute this in Jupyter Notebook. So here we are back in our Jupyter Notebook. Okay, so first let's create an array by importing NumPy. Import NumPy as np, right? Then a is equal to np dot random int, starting from, let's say, location 10 till location 100. We want 10 elements, right? And if I print a, this is our a, right? Now let's say I want to take let's say a I want to get a slice from 0 till location number 5 with a step size of 1. See what we got here. We got, this is location 0, 1, 2, 3, 4 and 5, right? So this location is exclusive. 5 is exclusive. See, you did not get you did not get this location. This element you did not get, fifth location element, right? Because that is exclusive, right? You are starting at 0, right? Going all the way till 4. This minus 1. This, if you are writing n here, you will get the elements till n minus 1. So 92, 44, 98, 82, 12, right? So this portion we got. This portion. Now let's say we want to let's see one more example here. A of, oh, so can I write this as a of colon colon? That means starting is by default 0, ending is, let's say, 5, and our step size by default will be 1. I did not mention that. So what will I get? I will get the same array. Even you can exclude the step size, a of colon, right, 5, right, right. By default the step size is 1. Whenever step size is more than 1, that time you need to mention the step size. Now let's see, we want to get the even numbers, even place numbers, or even position numbers. So we are starting at the beginning, going till the end. That means we are not mentioning the end, we are not mentioning the beginning. The step size is 2 now. You see what we got? We got this element 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We got this 92, then we got 98, we got 12, right? We got 78, we got 66, right? Similarly, if I want to get the odd place numbers, odd location number, right? So how can I get those? So a of odd place is starting at 1. You have to start at 1, go till end, take a step size of 1. It's a step size of 2, right? Starting at 1, right? You will get 44. If I show you, if you will get 44, which is on odd place, then 82, right, which is on odd place, then 51, 71 and 25, right? Okay, so that's how you can get the slice of the array. Also you can, the last we saw last time. Now let me get the array again here. A here, a. Inside this a, we saw that the last location is -1. Right? Index of last location is -1. If you start indexing from the end, the last location index is -1. This is -2. This is -3. This is -4, -5, -6, -7, -8, -9, -10. That is the indexing if you do sorry, If you do from the last location, if you do from the beginning, the indexing will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So can I take the slicing from the last location, right? By using this negative indices. Let's say I want to get the last 5 elements, these 5. So while taking this last 5 elements slicing, how can I do that? Start at minus 5, start at minus 5, go till the end. You need not mention the end, right? A of minus 5, starting is minus 5, last 5 elements, right? Last 5 elements, if you want to get, start at minus 5, because minus 5, from minus 5 you will get the last 5 elements, because minus 5 is the index of the last element, right? So minus 5. Now some people will say, why can't we start from 5 and go till end? This time, the size of the array is this 9 or 10, 10, right? Size of the array is 10. But if the size of the array is 100, if you start at 5, you will get 95 elements, right? So if you start at minus 5, you will always get last minus 5 elements. Minus 5, go till end, you need not mention the end, right? And take a step size of 1. You need not mention step size either, right? So let's see whether it works or not. A of minus 5, starting at minus 5, going till end, taking a step size of 1, right? You see what we got. Let us see here. You are starting at this 5 element, minus 5, right? 51, 78, 71, 66, and 25. You are getting this portion starting from minus 5, right? So that is how the slicing of the array can be taken. Now the important thing is to note is you need to mention the starting point, the ending point, and the step size. Starting point, start, end, and step. These are the important things you need to mention. So that was slicing of 1D array. Now let's see the slicing of 2D array. How can we take the slice of a 2D array, right? Let's see that. Okay. So here is our array A. A is equal to A, right? Let's convert this array A into 2D array. There are 10 elements in this array. 10 elements. A dot size, if you see, A dot size is 10. Now let's convert this into 2D array of 5 by 2. 5 by 2. A B is equal to A dot reshape 3 comma 5 comma 2. 5 comma 2. Right, now if I print B, this is our B, right? B is a 2D array now. B is a 2D array, right? So let's take a bigger array, right? B itself is B is equal to np dot random dot rand int. Let's say 10 comma 100 comma, we want to have a 2D array here now, whose size is, let's say, 2 comma, or let's say we want to have 40 elements here, so it will be 542, let's say 4 by 5. I'll take 4 by 5. I'll take 4 by 5, 20 elements, right? 4 by 5 size is 4 by 5. There are 4 rows, 5 columns, right? Let's say B. This is our B, right? This is our B. Now inside B, this is the 0th element of B, first element of B, second element of B, third element. 0th row, first row, second row, third row. This is 0th column, first column, second column, third column, and fourth column, right? Okay. So how can I get the slicing of this? How can I get the elements of this matrix B? Let's see that, right? So let's say I want to get, if I write B of, now here while doing slicing of 2D matrix, you need to do slicing of rows and columns separately, slicing of rows and columns separately, right? So B of, in 1D matrix, 1D array, we're doing slicing of only because there was only one row vector, right? So here we have to do slicing of rows and column, row slicing, comma, column slicing, row slicing, comma, column slicing. Again, for row, starting point, start, end, and step. Similarly for column, start, end, and step, right? Start, end, and step. So row start, if you want to start at 0th row, go till, let's say, row number 2, you need to mention 2 here, and step size, whether you want to jump by 2 or by 1 or by 3, whatever, you need to mention that step size. Similarly for column, start column, end column, if you want to end here, and what step size you are taking, whether you are jumping like this or directly like this, that you need to mention for column as well, right? Start, end, and step, row slicing, comma, column slicing. So let's see that. So let's say I write B of row. For row, I want to take only even rows. Let's say I want to start at 0, end at, let's say, I need not mention, I will not mention end. Let's say I want to go till the last locations, that's why I need not mention the end. So, and the step size is 2, right? Step size is 2. So I want to take only this. So let's see what we get. We get, if I don't write the column slicing, by default I'll get all the columns. See, I did not write the column slicing here. I did not write the column slicing. So by default I get all the columns, right? So here I got 2 rows, this row and this row, this row and this row, right? So similarly, now let's mention the rows also. Let's mention the columns also. Let's mention the columns also. So B of, if you are starting from 0, you need not mention the start. If you're ending at the last row, you need not mention it. The step size is 2. Now let's say I want to get only the even columns, that means 0, 2, 4, etc. Right? So again, if you are starting at 0 column, mention it, or you may not mention it, right? It's optional. End is by default the last, so I will not mention it, and the step size of 2. Now let's see what we get, right? You see what we got. We got we got uh, uh, we got this 1, 2, 3, and 4, right? 0, 1, 2, 3. We got this 51, right? 68, 51, 68, 66. From column 2 we are getting next 66, 75 we got, right? And then from column 4 we are getting 85 and 45, these elements. So you are starting, this is column slicing, this is row slicing, this is row slicing, right? So we got only that portion, right? That is how you can get the slicing of the array. Here also negative indices is applicable, negative indexing is applicable. This is -1, -2, -3, -4, right? Let's say we want to get only minus last row, right? We want to get last 2 rows only. Let's say last 2. This is -1, -2. I want to get only last 2 rows. Let's see how can we get only last 2 rows, right? So b of b of starting is at last 2 rows. No, start. I want to start at -2, go till end, right? And the step size is by default 1. Let's say. See, we got last 2 rows, right? We got last 2 rows. This row we got and this row we got, right? You see, last 2 rows. Similarly, the slicing is applicable for columns also. Negative slicing is applicable for columns also. Let's see the matrix again. This is b here, and now let's say I want to get this portion of the array. This portion of the array I want to get. I want to get this portion of the array. So this portion is inside the last two rows and last two columns. Last two rows and last two columns. I want to get only last two rows and last two columns, right? Right. Last two rows and last two columns. Let's see how can we get that. So here B of last two rows, you are starting at -2, going till end. Step size is by default 1. You need not mention it. Now last two columns, you are starting at -2 column. Last two column, this is -2, right? So this one is uh, -2. This is -1, -3, -4, -5 columns, right? So you want to start at -2, right? -2 and go till end. Go till end. You need to mention it, and the step size is 1. You see what you got, right? What you got is, if you see here, this portion exactly what we wanted. Similarly, you can do this slicing, by or you can take any slice of this array. If you want to take this portion of the array out, right? How can you take it? Is inside, this is column 0, column 1, column 2, column 3, starting sorry, row 0, row 1, row 2, row 3, column 0, column 1, column 2, column 3, column 4, right? So this falls inside row 1, 2, column 1, 2, 3, right? So you should mention, you should mention like this. This is what you should do. b of b of You want to start at row 1, go till row 3, which is exclusive, take a step size of 1, comma, you want to start at column 1, go till column 4, which is exclusive, take a step size of 1, right? So you get exactly the portion which we wanted this portion, right? Okay, that is how you can do array sampling, ND array or 2D array. Similar way, you can do slicing of multidimensional arrays also. So thank you so much for watching this lecture. We'll see the other topics in other videos. Thank you.